Here's your integrated 3 lecture for 12.1.2, solutions to trig equations. So in 12.1.1, you recognized that an equation can be always true, sometimes true, or never true. In the next few lessons, you will focus on trig equations that are sometimes true as you learn how to solve them and how to determine the number of solutions they have. Consider the equation cosine x equals a half. When is this equation true? What do the solutions to this equation represent? So for letter A, when is it true? I'm thinking you guys are going to know that it's true maybe when you look for cosine. The x values are cosine. So I can see cosine as a half at 60 degrees, which is pi over 3. On a unit circle, maybe there's somewhere else. Cosine is a half right over here at 5 pi over 3, which is 300 degrees. You might know that cosine can look like a graph. You may be aware of this, that cosine just goes on and on and on, and that the unit circle is just from here to here. So there are other, besides the two places on the unit circle where cosine x is a half, it would make sense that there are other places besides just 60 degrees and 300 degrees, because you can go around and around and around this unit circle. You can go off to infinity to the right and left of this graph, and you can find lots of places where cosine x is a half. And even if you look at a triangle, for cosine x to be a half, let's look at a triangle. So for cosine A, you know how cosine is adjacent over hypotenuse? That would be cosine would be a half here. Cosine A would be a half. But what if I made this a 2? And what if I made this a 4? Isn't it still a half? And what if I made it a 3 and a 6? So if you get the idea, there's a lot of places. There's actually an infinite amount of solutions. Not every solution, but there's infinitely many places or many values of x that can make this true. So solve the equation graphically. So I kind of did draw you a graph, but it wasn't a nice one. So I'm going to show you here's a Desmos graph of cosine x. And then I'm interested in finding out when is cosine x a half. So I don't know if you can see that. Cosine x is a half every place where the green and the blue are intersecting. And you guys are better with your calculators than I am. See, that's pi over 3, which wasn't that 60 degrees? We just looked at it a minute ago. Negative pi over 3. 5 pi over 3, we just looked at that a minute ago. But can't I go on forever and ever and ever and ever and ever? I sure could. I could keep going. I could shrink this so that we could see more of the graph. So just so you're very aware of that. So letter B, we want to say there's infinite solutions. That's how many solutions there are. Draw a unit circle showing the solutions. How many solutions do you see? So you can draw one, but I happen to have one sitting right here. So when you draw the unit circle, the places where cosine is a half, I mean, there's other halves around here, but they're negative. There's a negative half, cosine's negative half, but the places where cosine is positive 1/2 is right here at 5 pi over 3, which is 300 degrees, and pi over 3. So if you drew your unit circle, you could just draw it like that. These are the two spots on the unit circle here and here. Okay, and then on 12-20, it says solve the equation cosine x equals a half and show where the value given by the calculator can be seen on the graph and the unit circle. So I just grabbed this calculator because it was sitting around, and cosine a half is 0.5. I'm in degree mode, so I got 60 degrees. 60 degrees, so I need to show that. So it only shows me quadrant 1, 60 degrees. And then where would that be on my graph? Let's get the graph. Where did it go? Where's 60 degrees on my graph? I think that's this one. Pi over 3, which is the same as 60 degrees. And if you wouldn't have been in, I just happened to be in degree mode, but if I would have been in radian mode, then I would have gotten some decimal. Let's see. Okay, now I'm in radian mode, and I'm going to get the cosine. Oh, so my calculator is kind of nice because that's the same as pi over 3. Your calculator might give you this number. That's how many radians. That's the amount of radians that is equivalent to 60 degrees or pi over 3. Okay, so if you got that, it's not wrong. It's just that's what, if you took pi 3.14 and divided by 3, you get this. Okay, so that's just your decimal of pi over 3. All right, so 12-21, with your team, decide how many solutions there are to the equation cosine x equals a half. Justify your decision using as many representations as you can. How can you write all of them? So I would hope that if we were together and you were in class, you guys would all have your Desmos out, and you'd be looking at that graph that I showed you where there's a billion places where cosine is a half. Maybe you'd be looking at some unit circles. You'd be going, oh, it's all over the place, right? But how can you write that? How on earth can you write that? So I'm going to kind of just spill the beans and tell you how you can write that, because just in the interest of time. So we know that cosine of x equals a half. We know that x is equal to 60 degrees. We know it's equal to 300 degrees. We know 60 is the same as pi over 3, right? I think I should avoid the degrees because now we've been doing radians. So just remember pi over 3 and 5 pi over 3. Okay, so how can I write all of them? Like we know that if we're at pi over 3, I can go all the way around the unit circle and get another one. I can land there again. Whatever pi over 3 plus 2 pi is, like what is pi over 3 plus 2 pi? Well, I would need a common denominator. So I'd have to multiply the top and bottom of this by 3. So that'd be So if I went all the way around my unit circle 7 pi over 3, I'd land right back there again. So what we're going to do is to each of these two solutions that we see on the unit circle, we're going to go plus 2 pi n plus 2 pi n. And what that does is that tells me that this solution, it's found here at pi over 3, but I could keep going around the unit circle, around and around however many times I want, just the same way as I could keep going down this graph. This graph I can keep on moving down and keep on moving. There's one there, there's one there. They're all separated by 2 pi. Okay, so even if I want to go that way or that way, 2 pi n. N is however many times I want to keep going around and around. So this is the proper way to write all the solutions to this. It's the 2 pi n. You got to remember that. And then, so now we're ready for 1022. Says, how do the solutions to cosine of x equals a half relate to the value given by calculating cosine inverse on your calculator? So when I did cosine inverse on my calculator, what happened? Let's give me the cosine inverse again. I got pi over 3. Well, that is just my first quadrant of the unit circle. It's going to give me an angle measure in quadrant 1, or an angle measure between 0 and 0 and pi over 2. Or you can say it's an angle measure between 0 degrees and 90 degrees. Quadrant 1. That is what calculators give you. So that's why you have to be careful when you're using your calculator. And you have to remember the unit circle, because the calculator is programmed to only give you one of the many solutions that there are. And it's only giving you the quadrant 1 solution. It's up to your brain to remember that the calculator solution is just this little tiny part of your unit circle, and it's the little tiny part of the graph. So 12-23 says, list all of the solutions for each equation below. You may use your calculator, but you must write your solutions in exact form and represent your solutions both graphically and on a unit circle. So I'll try to go through these real quick. So it says 2 times cosine x plus 1. So I'm going to subtract 1 on both sides. And I'm going to divide by 2, and I'm going to get cosine x equals negative half. Okay, I just did some algebra to that down there. And then it says, list all of the solutions. Okay, so when is cosine x a negative half? I'm just going to use I happen to have this right in front of me. So cosine is the first part of the ordered pair. That's positive half. I don't want that. I'm looking for negative half. So it's at 2 pi over 3. And there's going to be another spot somewhere. Let's look for a negative half. And 4 pi over 3. So this